Hello, algebra. So we've talked about how to solve a system of equations by graphing. There's actually 3 different ways of solving a system of equations, and we're going to learn our second way today. So this is solving a system of linear equations by substitution, all right, by substitution. So we've been given 2 different lines here, y equals 2x and y equals x plus 5. We're going to start by just picking one equation and solving it for one variable. Doesn't matter if it's x or y. I'm going to pick my y equals 2x because I have y by itself. So my y is already solved. All right, my y is solved. It's by himself. Done. Second thing, it says to substitute into the other equation. So I'm going to take this and I'm going to substitute into my other equation. So my other equation was y equals x plus 5. In order to substitute it, that means I'm going to take my y out. Equals x plus 5. And I'm going to put in what y was from the first equation. Well, from the first equation, it was 2x. So that means this 2x is going to go in right here. So I'm going to get x plus 5 is equal to 2x. All right, so that's what I get. 2x equals x plus 5. Third thing says solve for the remaining variable. So I need to solve this for x. So if I have 2x equals x plus 5, I need to get x by itself. Well, I'm going to subtract x on both sides. So I have 2x minus x is just x. X minus x is 0. 0 plus 5 is 5. So I know that x equals 5. I know that. Hey, you have one variable. I need to substitute into an equation and solve. It doesn't matter which of these equations I pick. I need to take what I know about x and substitute it back in. So I am going to pick the first one for no reason. And I need to substitute x back in. So that means I get y equals 2. I take my x out and I plug in 5. Well, what is 2 times 5? It's 10. And then I need to have my final answer. So for 5, that means my final answer is some point xy. So my final answer is some point xy. So that would be 5, 10 in this case. And last but not least, I have to check it. All right, I have to check it. So if my 2 equations were y equals 2x and y equals x plus 5, I need to substitute in my 10 for my y and my 5 for my x for each and see that it actually works, that it does in fact equal 10. So 5 times 2 is 10. Does 10 equal 10? Yes, which we kind of knew because we used that one initially, right? Still have to show it. And then for our other one, we have a 10 equals 5 plus 5. Well, 5 plus 5 is 10. Does 10 equal 10? Yes. So is this my final answer? Yes, it is. We proved it. We checked it. We everythinged it. So our next one right here. This one again has a variable that's already been solved for us, which is lovely. So it's nice and easy to substitute in. So this is already done for us. So when we substitute it for number 2, we would have 6x minus 5y equals negative 19. Our y is already solved, which means we take out y and we're going to put in that whole thing. So 6x minus 5 parentheses equals negative 19. So we have 6x minus 5, and we're going to plug in negative 2x minus 9 is equal to negative 19. First things first, we see a number, we see parentheses, we always distribute. So that becomes 6x, and remember, distribute the negative with the 5, okay? Attach him. Don't leave the negative separate, attach him. So negative 5 times negative 2x gets us a positive 10x. Negative 5 times negative 9 gets us a positive 45. Hey, I can combine like terms. 6x plus 10x is 16x plus 5 is equal to negative 19. I can subtract 45 on both sides. So we get 16x is equal to negative 64. Then I need to divide by 16 on both sides. Ooh, sorry, it's a positive 16, my bad. And we get x is equal to negative 4, right? Because negative divided by positive is negative. Now that I know this one, I can pick either equation. I'm going to pick the first one. and I'm going to substitute it back in, right? Actually, I think this was 3, and this one's 4, because 3 is solving it, 4 is substituting it back in. So we've got y equals negative 2x minus 9. So we get y equals negative 2. I'm going to take my x out, and I'm going to put in my negative 4. So we get y equals negative 2 times negative 4 is positive 8. 8 minus 9 is a negative 1. So that means my final answer would be negative 4, negative 1. But I need to check that. So here's my check. We've got y equals negative 2x minus 9 and 6x minus 5, y equals negative 19. So we should have negative 1 equals negative 2 times negative 4 minus 9. So we get negative times negative is a positive, so we get positive 8 minus 9 is negative 1. Does negative 1 equal negative 1? Yes, so that one works. For this one, we take out our x, we put in negative 4. We take out our y, we put in negative 1. Negative 4 times positive 6 is negative 24. Whew, there we go. And then negative 5 times negative 1, negative times negative is a positive. 5 times 1 is 5. Negative 24 plus 5 is negative 19. Does negative 19 equal negative 19? Yes, it does. So yes, we have proven it. We have checked it. Let's take a look at the last example. I'm going to encourage you to pause the video for a second and then check your work. So our last example is right here. And it has the negative x plus y equals 3. 3x plus y equals negative 1. We solve for, I just picked the second one because I could subtract 3x on both sides, made it easier for my brain. And then I plugged it in. And what was nice was I didn't have any distributing, so we just had negative x minus 3x minus 1 equals 3. So we get negative 4x minus 1 equals 3. Add 1 on both sides. Negative 4x equals 4. Divide by negative 4, we get x equals negative 1. Pick either of these equations and plug it back in, right? So if you pick the first one, we get negative 1 plus y equals 3. And so when we plugged it back in, we ended up with a y equals 2. All right, y equals 2. Be careful, that negative is a positive. We have to subtract 1 on both sides. That's why we get 2. So our final answer is negative 1, 2. And of course, you should do a check. I did not show mine. And then there's another example right here that I did not include in our notes. But you can see we had to solve one of these. This time I chose to solve the second one for x because it was easier, right? I just had to add 4y and then x was by itself. Then I substituted into the other equation our 4y minus 5x. So we have to distribute that negative 5. Again, make sure that negative stays with the 5. Distribute it. Oh, hey, I already did this one. This is the one I did. No, I didn't. It's just really similar because it's got 16 and 55. All right, the next one that I want us to talk about is, as I flip my page here, there we go, is this guy. All right, we've got a drama club. And they are doing a production. It is $1,040 is what they earn. They sell a total of 64 adult tickets and 132 student tickets or children tickets. An adult ticket costs twice as much as a student ticket. So we want to write a system and solve it to find out what's the price. So we've got 1,040, right? And they had 64 adults and 132 students. So here we go, 64 adults, 132 students. Or I like to use C for children because S and 5 looks really similar. So just for the record, that's why I use C. And we know that this one right here says adult tickets cost twice as much as student tickets. So that means 2 C's buys 1 adult, right? 2 students tickets cost the same as an adult ticket. So now I just need to solve these. And I'm going to do it by substitution. Now, the nice thing right here is I already have this as an A equals. So I have A equals 2C right there. So when I go to substitute it, I'm going to take my 1,040 is equal to 64A plus 132C. I'm going to take out my A. And I'm going to put in 2C. All right. So 64 times 2c is 128c. And then I have to add those two together because they are like terms. That would be 260. Because that's 250. Yeah, 260 children's tickets in terms of cost. And then when I divide that, I had my calculator right here. And I covered it up with papers. There we go. So then when I divide that, 140 divided by 260, we get 4. So divided by 260 on both sides. So we know that the cost of a student ticket was $4. Then we have to find, and I'm just going to use this one, 2c equals a. So I'm going to substitute in for my c 4. And lots of you can do that math in your head, and you're looking at me going, well, that's $8 is how much an adult ticket costs. You're right, it's $8. So now I know my C and my A. I need to write that as a coordinate pair. So I'm going to go with 4, 8. And then I need to check it. So 1,040 equals 64. I'm going to put in my 8 for adults plus 132 and 4 for my C. See what I get for that. So 64 times 8 is 512. 132 times 4 is 528. Well, if I add those together, I get 1,040. So that worked. And then I need 2c equals a. So that would be 2 times 4 equals 8. Does 8 equal 8? Yes, it does. So I have proven that this is, in fact, the solution for both of those. All right, I have proven it. So the next one that we want to look at is this guy. So this says that there is a total of 64 students in drama club and yearbook club. So I'm just using drama and yearbook, right? And I put an and because that's adding. So there should be an equal. So this is a very straightforward word problem to an equation. The next one's a little trickier because it says the drama club has 10 more students than yearbook club. So that makes us think that drama has 10 more, would be adding, right? But that means that drama is bigger, right? Drama is bigger. So really, it would be yearbook club that has to have 10 added to it to make it equal drama, all right? So you could do D equals 10 plus Y if you wanted to. I chose to do it as, oh, well, if I take 10 away from drama club, that gives me the population of yearbook club. So it doesn't matter. Both of them are fine. I have a nice handy yearbook club already solved. So I've got y equals d minus 10. So I can substitute that in for 64 equals d plus y. So I can substitute that in here. So I get 64 equals d plus d minus 10. So that means I've got 64 equals d plus d is 2d. I have to add 10 on both sides. So I get 74 equals 2d. And then when I divide by 2, we end up with 37 equals d. So I know, you couldn't see that, sorry. So I know that there are 37 students in drama club. I need to figure out how many are in yearbook. Well, I'm going to do d minus 10 equals y. So 37 minus 10 equals y. That means I have 27 students in yearbook club. And again, you couldn't see it. I'm doing really bad that day. So that means my coordinate pair is going to be 37, 27, right? 37 in drama, 27 in yearbook. And for our school, it's actually a class, not just a club. So I need to double check. So I need to do d minus 10 equals y, and then 64 equals d plus y. So for d minus 10, that would be 37 minus 10 equals 27. Does 27 equal 27? Yes. For this one, it'd be 64 equals 37 plus 27. So that would be 64. Does 64 equal 64? Yes. So have I proven it? Yes. I'm going to encourage you to write out the words in this one, okay, and not just the coordinate pair. But there is another word problem, all right, and this one says a farmer plants corn and wheat, so corn and wheat in a 180-acre farm. So that's this guy. The farmer wants to plant 3 times as many acres of corn as wheat. So that means I have to take my wheat to times it by 3 to get the corn. Okay, so I see a common mistake of 3 times corn than wheat. And that is not the case, all right? It's 3 times, and you have to times it by the wheat to get the corn, right? There's 3 times more corn than wheat. So be careful with those. I know that those are tricky, so be careful with them. So we want to solve this one. I'm going to give you guys the opportunity to do that. Email me if you have any questions. I'm happy to help.